Hello friends, welcome to AdWolves, and today we are going to find the voltage across the 20 ohm resistance. Okay, and as you see, this voltage is actually the voltage which is control voltage. We call this as a Vx, as a control voltage. Why? Because you can see over here, this is a current source, and it is a control current source because the current value is depend on the value of Vx. Similarly, this is a voltage source which is a voltage control voltage source because the value of the voltage is depend upon the value of Vx. Okay, so we need to find the Vx. Okay, and that is across the 20 ohm resistance. Okay, so what we going to do to find the voltage? Remember, in network theory, whenever you are asked to find the current, you apply KVL. Remember, when asked to find current, what we do? We use KVL. KVL. And similarly, when we are asked to find the voltage, when asked to find voltage, what we use? The counterpart of KVL, that is KCL. Okay, so remember this two thing whenever you're going through a network analysis. When they are asked to find a current, we use KVL, and when they asked to find a voltage, we probably use KCL. Okay, so let's begin with this problem. Let's see how to find voltage across the 20 ohm resistor. Before solving this problem, let me tell you this, that this current source of 0.5 Vx is actually flowing outward, in outward direction with respect to point P. Okay, so this is my reference point. Why? Because I need to find the voltage across 20 ohm resistance. So this branch and the point which is the junction at which it is cutting down the branch, that junction is called P junction. Okay, so in respect to P, this current, that is 0.5 Vx current, is actually flowing in outward direction. Okay, am I clear? This current is actually flowing in outward direction. The 5 ampere current is actually coming inside, or coming towards the junction P. Okay, so similarly, let me also label the other current direction which is necessary. So this is the other current direction, that is, this current is the branch of P. The current in this branch is flowing in outward direction. This current is flowing in outward direction. Okay, so you can see only one current, that is 5 ampere current, which is flowing towards the junction P, and other currents are just going outside. Let me also label the current. Okay, so assume this current to be I1, this is I2. Okay, why I assume label this current as I1 and I2? Because I don't know the value of this current. In otherwise, the value of this current which is flowing in this branch, I know the value, that is 0.5 Vx. Okay, similarly, the current flowing inside the inside or towards the P, I know the value, that is 5 ampere. Next thing we need to know is this, that what is the voltage at this point? Okay, what is the voltage at this point? You can see the 8 ohm resistance is parallel with a voltage source of 0.25 Vx. So the voltage at this point is nothing but just 0.25 Vx. It is just easy to understand. Okay, no rocket science to understand this key. The voltage at this point is what will be the voltage. Okay, how we will calculate it. don't worry, because the network is already provided that the branch, the 8 ohm branch is parallel with some voltage value, and that voltage value is nothing but the voltage of this point. Okay, are you getting? So let's begin. Let's apply KCL. Okay, so by saying that, by a- applying KCL, let me say that applying KCL, applying KCL at point P. So this is my point P, and I'm applying the KCL at this point. I know this point, the current is going in outward, this is coming inward, this is going outward, and this is going outward. So what I will write, the 5 ampere current is coming inward. So only one current is coming inside the junction, that is P. Otherwise all the current is going outside. So this is outside current, and what is its value? 0.5 Vx. So I will write 0.5 Vx plus this current, that is I1 current. You know that this is I1. So I1 plus I2. Okay, so following this equation, we can substitute the value of I1 and I2. Vx, this is not a I, it is Vx plus, what is I1? I1 is Vx upon 20 ohm resistance, Vx upon 20 ohm resistance. This is just a Ohm's law I applied. Okay, the value of I, current equals to voltage upon resistance. So the current flowing in this branch is just a Vx upon 20. Similarly, the current flowing in this branch, okay, we know that the voltage at this point is 0.25, and this point voltage is Vx. Okay, so the current flowing in this branch, that is I2, is nothing but Vx minus 0.25 Vx upon 10 ohm. So Vx minus 0.25 Vx upon 10 ohms. Now you just need to take the LCM, and by taking LCM you will get, that is 100 is equals to 2.5 Vx. Okay, so therefore our Vx value will get Vx equals to 100 upon 12.5. By division you will get the Vx value to be 8 volt. Okay, so the Vx, that is required voltage, equals to 8 volt. This is the value of Vx. I hope you understand this circuit and you followed what I taught. So if you like our video, please subscribe our channel and share as much as possible to your friends, to your colleagues, so they can also get benefit of understanding the electrical network. And thank you for listening.